Hey guys, welcome back to another evening of online calculus. So tonight we're going to talk about elasticity of demand. And I want to start by talking a little bit about what elasticity is and what products are elastic versus inelastic. So let's start with a product that is very inelastic. And the best example we have right now in our society is gasoline. As the price of gas rises, we do not stop our behavior. Most of you are too young to remember Hurricane Katrina, but during Hurricane Katrina, gas prices in the Atlanta area went from about $2.25-ish per gallon up to over $4.50 a gallon. Did I stop driving to work? Did I stop driving my children to their hockey practices and gymnastics practices and all of those things? No. I grumbled a lot when I went to the gas station, but I still had to buy gas. Okay? An example of something that is elastic: Oreo cookies. If you go into the grocery store and Oreo cookies have gone up by $2, you're not going to buy Oreo cookies. You are probably going to look around and find some other cookie that you like and substitute it. Okay, so that's what's going to make a product elastic or inelastic, is whether or not there are substitutes, readily available substitutes for that product. Okay, now even with that, as prices increase for any given product, we're going to start out that it's going to be inelastic, meaning I can raise prices on products. You know, if Oreo cookies are low enough and the price goes up, we're still going to buy them. But there does come a price where we decide that we are no longer going to buy them. Okay, so that's what elasticity is. And, you know, even though certain products are more elastic than others, there is some inelasticity and elasticity for each product. And we're going to look at that a little bit. But I want to start out looking at this formula here. E of x equals negative. Yes, I've drawn an arrow there to highlight the fact that there is a negative as part of this function. X times the derivative of your demand function, and that is divided by the demand function. Now, in this case, x is your price. That's the price we're charging, because elasticity is going to be a function of the price we charge. Okay, so x is the price. The demand function also is going to be based on our price. So x is just your input variable. So keep that in mind, because we could use a different, you know, we could just as easily do E of P. Everything would be P negative P D, sorry, that's supposed to be D prime P over D of P, right? Px, those are just your input variables. You can call them whatever you want, but I want you to see that, because I know that on your quiz and test, it is written as a P and not an X. So it works either way. Just remember whatever they're defining our input variable as, whether it's a P or an X. Okay, so again, elasticity, you'll have a negative in the function, and then it is your price, X, times the derivative of the demand function, and that's going to be divided by the original demand function. Okay, so talk a little bit about, so when we get that elasticity function, and I plug a price into that elasticity function, if I get a value less than 1, that means that at that price, we are inelastic, which tells me that increasing the price means that I'm going to increase my revenue. Okay? When e of x is less than 1, okay, when e of x is less than 1, I'm sorry, greater than 1, I'm backwards tonight. Okay, then that product becomes elastic, meaning that we're going to lose so many customers that our revenue is actually going to decrease. Remember, revenue is price times quantity. So the price went up, that portion of that function is higher, but the quantity that's going to be demanded is going to go down. So our total revenue is going to decrease. If we could get e of x to equal 1, then that tells us where total revenue is maximized. Okay, so when I ask you what it means for e of x to equal 1, this is what I want to hear. Revenue is maximized. Yes, it is also unit elastic, but no one cares about that. We care that total revenue is maximized. Okay. So here is our first example. We have elasticity of demand for video game rentals. These days, we would not rent physical video games probably, but they're still doing that here. So the first thing we want to do is find the elasticity of demand for this function. Here's our demand function. Okay, our quantity demanded is what we get when we plug a number in here. X is the dollars per rental. So E of X, okay, remember we have a negative here. This time our input variable is X, so X goes here. The derivative, E prime, is going to be negative 20. Okay, so I'm going to put negative 20 here. And then the demand function, which is 120 over minus 20x. Okay, and then let's simplify that a little. So we have negative. Now, we've got to give this negative to either the top or the bottom. It can't go in both. So I'm going to go ahead and move it to the top. So I have negative x times negative 20, which gives me a positive 20x over 120 minus 20x. And that does simplify to x over 6 minus x. Okay, so that is our elasticity as a function of x, one of those two formulas. Okay, then we want to find out what the elasticity is at a price of $2. So we want E of 2. So let's see what that is. We have 2 over 6 minus 2. So we have 2 over 4, which is 1/2. So at $2, this is inelastic. Okay, let's try that again at $5 and see what happens. We have 5 over 6 minus 5, which is 5 over 1. So now we are elastic, right? That is definitely a number greater than 1. Okay. Part C says to find the value where E of x equals 1, and then say what the significance of this price is. Well, the significance of that price is going to be, so let's remind ourselves, E of x was x minus, sorry, over 6 minus x. Okay, so we want to take that function and set it equal to 1. Okay, I have a fraction on the left-hand side, so the way we get rid of a fraction is we multiply both sides by the denominator. Okay, we do that because on the left-hand side, that's going to cancel out. So we're left with x. And on the right-hand side, 1 times 6 minus x is 6 minus x. Okay, let's add x to both sides. So we get 2x equals 6, which means x equals $3. Okay, so that is the price where the elasticity equals 1. What does that tell us? It told us to interpret this price that at the price of $3, revenue is maximized. Okay, so that is what that tells us. All right. And that is just notes. We already did all that. Oops. Okay. That is another example that you can do. Part A, we did not do in the clicks video example, but part A, the find the quantity demanded, means that you would take this 35 minus 7x, the d of x, and plug straight into that. So this one would be d of 2 for the $2 is 35 minus 7 times 2. So 35 minus 14. So at the price of $2, there's 21 packs sold a day. Okay, the rest of this is the same as the last example. Okay, and that is everything for elasticity of demand. So this will show up on your next quiz. It will have part A, where you have to tell me the quantity demanded at a certain price. It will have find the elasticity of demand, so you have to get me that function. You will have to find the elasticity at a certain price and tell me what that means. You also have to find where the elasticity is equal to 1 and tell me what that means when elasticity equals 1. All right. Hope you're having fun while you are quarantined. I know that fun's probably not the right word for it, but wish that I could see you soon, but I guess that's not going to happen this semester. So I will talk to you after spring break.